not only can we convert back and forth between rectangular and polar coordinates, we can do the same thing with equations. Here I've been given the equation r equals 4 cosine theta. This is in polar form. So we know that x equals r cosine theta. So if we look at this cosine theta, if we only had an r right here, we could change that to x. So we're going to manipulate the equation a little bit. We're going to multiply each side by r, giving us r squared over here and 4r cosine of theta. Now we can put an x in place of the r cosine of theta, and right here r squared is actually going to be x squared plus y squared. So we end up with x squared plus y squared equals 4x. And that's we've got what we want as far as getting it in terms of x and y, but we can move some things around here and make this equation a little prettier. So we've got 4x here. Let's subtract that over to this side and leave this side with 0. Now I can complete the square. So we're going to take the negative 4, divide it by 2, and square it, and we're going to get 4, and we'll add 4 to the side as well. And we take this trinomial right here, x squared minus 4x plus 4, and just factor it, giving us x minus 2 squared plus y squared equal to 4. That's actually the equation of a circle, which we've got right over here. That's what the graph of this would look like. Okay, so now here's an example where we're given the Cartesian equation and we want to find the polar form of it. So we've got x minus 3 squared plus y minus 2 squared equal to 13. And yeah, so we're converting that to polar form. Let's go ahead and expand these out. So we've got x squared minus 6x plus 9 and y squared minus 4y plus 4, still equal to 13. 9 and 4 are going to add up to equal 13, so we'll take 13 from both sides, giving us 0 over here. And now we've got x squared plus y squared. We know that's equal to r squared, so we'll put the r squared right there, and we can take x and y and substitute r cosine theta and r sine theta in for those. So that's what we're left with here. If you notice, we got an r in each term, so we can take out the r and put that here. So we've got r times r minus 6 cosine theta minus 4 sine theta. And this is kind of like when you are factoring and you get the variable outside of here. Either this is going to be equal to 0 over here, or this whole term is going to be equal to 0. So either r equals 0, or r minus 6 cosine minus 4 sine, r minus 6 cosine of theta minus 4 sine of theta equals 0. That's a mouthful. Well, since r is equal to 0, that's just going to be on the origin, so the point's really just included anyway. So we don't really have to worry about that one. So this is actually what we're going to use to find our equation. And if we just add these over here, we're going to get r equals 6 cosine of theta plus 4 times the sine of theta.